Welcome friends, welcome to the part 4 of the series in which we are doing the derivatives. Okay, so in the previous video we saw about the quotient rule. This was the quotient rule. So this quotient rule means suppose if two functions are divided in this form, so we already have seen this formula, and this second formula we already learned. This was the product rule. Okay, these two formulas are the main basic formulas which we can use in differentiating different types of expression containing different types of functions, okay, like trigonometric and algebraic together. So right now, as we discussed in the previous video, that we will learn about some more of the different types of trigonometric functions. Like now I've written here the different types of the trigonometric functions. Like the first of all is a tangent, tan of the x. So tan x has a derivative of sec square x. So that is the derivative of tan x with respect to the x. This is secant square x, sec square of the x. And cot x, which is the reciprocal of the tan, but the derivative of cot x is negative cosec square x, or sometimes we also write this cosec as in some short form as CSC. So you can use any of the so that can also be written as negative of the CSC, which is cosec square x, okay, cosecant square x. And the derivative of sin secant of the x at the sec of the x equals to sec s times tan x, okay. So this is the derivative of secant of the x. So this formula we have to keep it in the back of our mind so that we can use it whenever needed, okay. And the cosecant of the x, this is equals to its derivative is equals to negative cosecant x times cot x. So these are the remaining four formulas, leaving the previous two which we already discussed in the last video, like the derivative of the sin x, that was cos x, okay, and the derivative of cos x, that was equals to negative sin x. So these are all the six trigonometric ratios and with their derivatives, okay. So now let us do one example, a question maybe in which we will be using first of all maybe either of the two rules, okay. So let's see. So let me just copy the questions as I've already prepared it so that we can save some time. Okay, so this question says if y equals to I think the space will be less, so let us move to the next page, okay. Okay, so in this question the function y equals to 4x plus 5 sin x over 3x plus 7 cos x, and we need to find its derivative. So how can we do so? So you can easily recognize the pattern of this function is in the form of the fx over gx, okay. And we just now saw that formula how to differentiate. So let us copy that formula from there, that quotient rule formula, and we can use this quotient rule formula and differentiate that function. Okay, so this is the formula. Now let me just circle it, okay, so that you can distinguish it. Now if you see here, the function y equals to 4x plus 5 sin x over 3x plus 7 cos x. There are two ways to solve it, like to differentiate it. First of all, we can just simply write this formula, replace the fx by 4x plus 5 sin x and the gx by 3x plus 7 cos x, and do it directly. Or maybe we can separately differentiate the function fx, which is the numerator, 4x plus 5 sin x, and then differentiate the function gx, which is the denominator here, which is 3x plus 7 cos x, and then just put the derivatives in this formula using, okay. So both of them are okay, but I feel the second one is an easier way in comparison to the first one, especially if you are a beginner. If we slowly and gradually get hold of it, then we can directly use the formula and solve it as it is. Okay, so let us see. So if we assume, we can say, let us assume the function fx equals to 4x plus 5 sin x, and the function gx equals to 3x plus 7 cos x. So we can say derivative of the function fx with respect to the x, this is equals to, what is the function, that is fx is 4x plus 5 sin x with respect to the x. Okay, and we know here 4x is added to the 5 sin x, so these two are different functions sort of. So we can simply just differentiate them separately and put a plus, or add those, like, so this is like derivative of the first function is 4x with respect to the x plus derivative of the 5 times sin x with respect to the x. And we know if any coefficient or any number is multiplied to a function, we can just put it outside of the operator d over dx. So this is 4 times derivative of the x with respect to the x, and plus this is 5 times sin x, so we can put 5 outside of the bracket. So this is 5 times derivative of the sin x with respect to the x. Now this dx over dx, we already saw in the previous video that derivative of x with respect to the x, this is equals to 1. Okay, so we can just simply replace that. Okay, here, so this will be equals to 4 times 1, this is replaced by 1 plus 5 times, we just now saw that the derivative of sin x with respect to the x is cos x, so that is cos x. So after multiplying it, 4 times 1, this is 4 plus 5 times cos x. So we can say like the derivative of the fx with respect to the x, that is derivative of the 4x plus 5 sin x with respect to the, this is 4 plus 5 cos x. So this is the derivative of fx with respect to the x. We'll be using it. Okay, so we should just circle it. Okay, now similarly we can differentiate the denominator, which is 3x plus 7 cos x. So let us differentiate the denominator. So derivative of the denominator gx with respect to the x, this is equals to derivative of the 3x plus 7 cos x. So we can similarly break it in 2 parts, and like we can do it step by step, or we can just maybe think in our mind, oh, we have to first of all differentiate this. So this is like 3 as a constant, so 3 times derivative of the x, and that is 1, so that is 3 times 1. Okay, this is also okay, because we don't need to show each and every step in almost every problem, because the problems might be very lengthy sometimes, not as these are simple problems. So we can skip some steps like I am doing it right now. So plus 7 times, we can put a plus as the plus is there. Okay, and then we can just write 7 times cos x. So 7 is multiplied to cos x, so we can just write 7 there. Okay, and times the derivative of cos, and we know derivative of cos is negative sin x. Okay, the derivative of cos x with respect to the x is negative sin x, as we already have seen this here. Okay, cos x, this is negative sin x. So now what we can do is like we can just simplify it and get this result. So this will be like 3 times 1, which is 3, minus 7 times sin x, which is 7 sin x. So we can say this is like, oh, derivative of the function gx with respect to the x, this is equals to 3 minus 7 sin x. And what is the gx? Gx is actually 3x plus 7 cos x, whose derivative is 3 minus 7 sin x. Now we'll be using the derivative of the fx and the gx in our formula. So let us use the formula. First of all, let me again copy it. I'm just copying it so that we can see what is happening and how we are applying the formula. So this is the formula, and here we have to differentiate the function 4x plus 5 sin x over 3x plus 7 cos x with respect to the x. The numerator has the function fx, So the numerator is fx and the denominator is gx, and we already have the result from the previous video that the derivative of the fx is 4 plus 5 cos x. Okay, so maybe we can just put it here somewhere. This is for the fx, okay, 4 plus 5 cos x, and for the gx we can say the derivative of the gx, this is equals to 3 minus 7 sin x. Three minus 7, so maybe we can just put 3 minus 7 sin, okay, above this, okay, so that we can understand. And now let's use it. Okay, so we can say this is equals to first of all derivative of the fx, which is 4 plus 5 cos x. So we can say 4 plus 5 cos x times, and then times gx. What is gx here? 3 x plus 7 cos x. Okay, so cos x, not cos 2x. And then we'll put a minus sign as in the formula, and then fx is what? 4x plus 5 sin x. And times derivative of the gx, which is 3 minus 7 sin x. 3 minus 7 sin x. And all of that over the square of the gx, means the square of denominator, which is 3x plus 7 cos x. So this will be 3x plus 7 cos x whole square. Okay, so this is now the expression which we just need to simplify to get the derivative of this function fx over gx, which is 4x plus 5 sin x over 3x plus 7 cos x. So this will be, maybe we can just multiply, we can just 4 times 3x and then 4 times 7 cos x. So 4 times 3 will be 12x, and then 4 times 7 will be 28 cos x. And then we can say 5 cos x times 3 is 5 times 3 is 15, so that is like 15x cos x. And then 5x times 7x, sorry, 5 cos x times 7 cos x, so 5 times 7 is 35, and cos x times cos x will be cos square x. As we say, x times x is what? X square, similarly. And then we can put a minus symbol, minus after that, and then we can similarly multiply this. So 4x times 3 will be 12x, 4 times 3 is 12, and 4x times 7x, and with the negative, so 4 times 7 is 28, positive 4 times negative, so positive times negative is negative, so 4 times 7 is 28 x, and then sin x. Okay, and then we can say like 5 sin x times 3 is 15 sin x, and maybe 5 times negative 7 is negative 35, and sin times sin is sin square x, so that is negative 35 sin square x. And whole of that over what is in the denominator, that is simply 3x plus 7 cos x whole square. Now what we can do is, like, we can simply just remove the brackets and see what we will get. So we will have, this is 12x, let me go to the most left so that I want to do it in a single line maybe. So 12x plus 28 cos x plus 15x cos x plus 35 cos square x. Okay, and then minus 12x, because negative of positive is negative, and the negative of the negative is positive, so that is 28 x sin x, and then negative of the positive is again negative of the positive is negative, so that is negative 15 sin x. Oh, I got space. The negative of the negative is positive. Finally, this is plus 35 sin square x. This is all in single line. Okay, just due to lack of a space, I need to move into the second line. All of that over 3x plus 7 cos x whole square. Now you see the 12x plus and the minus will be cancelled, And one more thing which we can simplify is like is 35 cos square x plus 35 sin square x. When we'll do this, you see, when we'll do this thing, 35 cos square x plus 35 sin square x. So we may take 35 as common, so it will be 35 times cos square x plus sin square x, and we already know that cos square x plus sin square x is equals to 1 by the trigonometric identity. So that will be 35 times 1, because cos square x plus sin square x, that is equals to 1. We need to remember these identities also, because this is calculus, we will use everything from this trigonometry also. So 35 times 1 is 35, okay, that is 35. So that means if we add these two terms, 35 cos square x plus 35 sin square x, that will be reduced to 35, okay. So this will help us in further simplification, so we can do it. So this will be like 28 cos x plus 28 x sin x. So we can like just copy this. This is equals to 28 cos x plus 28 x sin x. So we can take 28 as common, so that will be 28 times cos x plus x sin x, okay. And then similarly we can write 15x cos x plus minus 15 sin x. So we can take 15 as common, it will be 15 then times x cos x, 15x cos, okay, and then minus sin x, because 15 is 15 sin x. And then we can just, the only two terms will be left is 35 sin square x plus 35 cos square x. So this will be eventually 35, as we already shown it here. All of that over 3x plus 7 cos x whole square. So this is the simplified form of the expression which we got after applying the quotient rule, and we can say this is our result, okay. So this is how we do it step by step. So let us now move on to the next question, which is, so this question was based on quotient rule. So right now I want to take a question which is based on the product rule, okay. So how will we sorry, let me take the question first of all. Let me take the second question. I just wrote this already so that we don't have to think about what to do in this session, okay. So this question is like, if y equals to x plus sec x times x minus tan x, so what is the derivative? Okay, what is this derivative? We have to find, okay. We have to find the dy over dx in this case, if y is equals to this thing. So let us do it let us do this thing in a fresh page. So this time we can easily figure it out. This is in the form of the product of two functions. You see, this can be considered the first function fx, and this can be considered the second function gx, and this is in the form of fx times gx, okay, fx times gx. So now we can say y is equals to x plus sec x times x minus tan x. So if we solve it, let us solve it, okay. So for this solution, sorry. So we say y is equals to x plus secant x times x minus tan x, okay. Sorry for the background noise, I think there's somebody in nearby is making some noise, sorry for that. So this is y equal to x plus sec x times x minus tan x, okay. So here we can say like the fx equals to this x plus sec x, and the tan x equals to gx equals to x minus tan x. So maybe I just want, for this one I just want to directly apply that rule, quotient rule. What is that? Sorry, I directly want to apply the product rule, okay. And that rule is, let me just copy it, okay. I just don't want to do it in detailed way, so that you can also see how can we directly apply the quotient or the product rule if needed, okay, due to lack of time if there is some need. So let me just copy this rule from there. I know the streaming is already lengthy, but It needs some time, so I can't help it out. Actually, I need to do at least 2 questions, I feel. Maybe I'll create some split some videos and create unique videos for 1 question only later on. Okay, so for this one is like the this is one is the product rule. Okay, so fx times gx. So if you consider fx as the x plus secant x, okay, and the gx is x minus 10, so you can say the derivative of the x plus secant x times x minus tan x over dx. Okay, so this is equals to what? This is equals to, we can say fx is what? Fx is like x plus secant x. Okay, so we can say this is equals to, you can change the line. Okay, this is equals to derivative of the x plus secant x. Okay, because this is the first function, which is fx. This is our fx and this is our gx. Okay, so with respect to the x times x minus tan x. Okay, and then we'll put the plus sign, so plus the derivative fx times fx is x plus secant x time the derivative of the gx. What is gx here? Gx is x minus tan x with respect to the x. Okay, and so this is the application of the product rule, and we'll just replace the fx by the x plus sec x and the gx by x minus tan x. Now we will differentiate it. Okay, so let's differentiate it step by step. So the first of all, x plus sec x, secant x. So what is the derivative of x? We already know the derivative of x is 1. Okay, and then there is a plus sign over there, so we'll just put a plus, copy it there, and then the secant x is there, and we saw it in the formula, and the derivative of secant x is secant x into tan x. You see it from here. Yeah, you see the derivative of the secant x is secant x times tan x. So we will use this result. Okay, fine. So this will be like plus, copy it. So this is secant x times tan x as the derivative of the secant x or sec x. Now times this is x minus tan x. We'll just copy it because this is simply multiplied, and then a plus. So let me change the angle. Plus, then we'll just write x plus secant x. Okay, x plus secant x times the derivative of x minus tan x. So what is the first function here? X. So the derivative of x is 1 again, and what is the derivative of tan x? So the derivative of tan x is actually 1 minus, sorry, secant square x. Secant square x. You see, secant square x. So we'll just use this result, secant square x. Okay, for the derivative of tan. So this is secant square x. So this is now what we need to do actually, and this is the simplified. This is like we got after differentiating, and we can see if it any further simplified, maybe we can just multiply it simply like we did. So this is like 1 times x is x, secant x times tan x times secant x. So sec x tan x times tan x will be sec x tan x square. We'll put a plus there. Sec x tan x, sorry, tan square x, not tan x square, tan square x. Okay, and then we'll multiply 1 with the tan. I actually just change the order. First of all, let me multiply the 1 with both. Okay, 1 with the x and 1 with the tan. So 1 times x is 1, and then 1 times tan is like just tan x. Okay, simply tan x, and then secant x times x. So this is like x times secant x times sec x tan x. Okay, and then sec x times tan x. So like sec x minus there because positive times sec x is negative. So this is sec x times tan x times tan square x. Okay, and finally this will be like plus. So this is the expansion of this. Okay, expansion of this is this all of the 4 terms, and when we'll multiply these two, this will be like x times 1 is x again, and the next time sec square is minus x sec square x, and sec x times 1 is sec x simply, and sec x times sec square x plus of minus is minus 1, that is negative sec cube x. Okay, because this is power 1, this is power 2, so they have the same base sec x, so that 1 plus 2 is 3, because we know x to the a times x to the b is like x to the a plus b. The exponents are added when they are multiplied with the same base. So now we can only just, the only thing that we can simplify is like we can just add this x plus x, okay. So this will be 2x, okay, this will be 2x. And other than this, I think everything else will be copied, because no other like terms are there. There is tan x there, minus tan x, and then tan x, and then there is a plus sec x, okay. And then there is like plus x sec x tan x, and then there is minus sec x square x tan x, sorry, minus sec x tan square x, and then there is minus x sec square x, and then there is minus secant cube x, okay. This is 1 2 3 1 2 3 4 5 6 and then 7, yeah. So this is the result for the, even though we can leave it over here, that's not like mostly necessary to expand it, but just maybe sometimes in the trigonometric functions we have some further simplifications using the identities, that's why just to expand it, okay. So this is how we'll expand it, and we'll differentiate using the product rule and the quotient rule. In the next video I'll take some more good questions and we'll use the product rule and the quotient rule in the next video. In maybe 2 or 3 more videos I'll try to cover it up with the same. And also we are left with the exponential function and the logarithmic function, and then we'll slowly gradually move on to the topic of the chain rule, which is pretty important, and because that is where the complexity starts. So till then, if you have any doubts or comments, then please do ask, or you can also mail me at my email ID, which is actually mathstutor for w, okay, for w at gmail.com. You can ask me your queries there, and if you're watching it right now, then please give me some suggestions as how can I improve my streaming. You can just comment in the comment box, and if you're watching it after the streaming, then also you can ask me and give me suggestions. And also please share and subscribe it if you feel it is beneficial for you, and it can also be beneficial for your friends. And thank you for watching this video. Hope to see you in the next one, okay. Bye bye.